Hello, welcome back to my channel. In this video, I'm going to explain the concept of analysis of variance, popularly known as ANOVA. The earlier hypothesis testing videos discussed are only applicable when dealing with two samples. For example, if I'm interested in finding out if the beverages that people drink affect their body weight, let's say the beverages are tea and milk. In order to find out if there is difference in the body weight of these individuals who consume these beverages, you collect sample of people who consume these drinks and record their weight. Let's assume group 1 represents the weight of those that consume tea, while group 2 represents the weight of those that consume milk. To analyze this data consisting of two groups, we make use of t-test. Basically, what t-test does is testing the significant difference between two sample means. But when you have the third group, say people that consume hot chocolate, then you use different approach to analyze this data. That approach is known as ANOVA. That is the acronym for Analysis of Variance, also known as F-test. This implies that ANOVA or the F-test is an extension of t-test. Please note, t-test make comparison between two samples, while ANOVA make comparison between three or more samples. Once a researcher collects data from three or more samples, it makes using two-sample hypothesis or the t-test invalid. Question now is, what is ANOVA? ANOVA is an important technique or arithmetic progression used to partition the total variation in a set of data into several sources of variation. So the total variations in these three groups consist of two parts. The first variation is the variation within each group. This variation happens because individuals within each group recorded different body weights. The second variation is the variation between each group. This variation happens because the drinks for each group isn't the same. We could see that within each group, individuals will look pretty much alike. There is no much variation. Why variation is so obvious between the group? In this case, you conclude that it is the drinks that made the difference in weight and not the people. Before conducting an experiment, a researcher first identified those sources of variation that he considers important and chose a design that will allow him to measure the extent of the contribution of these sources to the total variation. Why use ANOVA? ANOVA is basically used for two purposes: to estimate and test hypotheses about population mean, to estimate and test hypotheses about population variance. The hypothesis for this set of data will be: the first one is the null hypothesis, represented with H0. This hypothesis states that there is no difference in the population mean of individuals in the three groups. That is, the weight of individuals in group 1, 2, and 3 are equal. This implies population mean in group 1 equal population mean in group 2 and that of group 3. The second hypothesis is the one referred to as alternative hypothesis. Alternative says that there is difference in the population mean weight of individuals in the three groups. That is, the weight of individuals in group 1, 2, and 3 are not equal. So here, is either the mean weight of individuals in each of the groups are not equal, or the mean weight of individual in group 1 is not equal to that of group 2, while the individual mean weight in group 2 is equal to that of individual mean weight in group 3, or the individual mean weight in group 1 is equal to the individual mean weight in group 2, while that of group 2 is not equal to that of group 3. Various types of ANOVA: one-way or one-factor ANOVA. One-way ANOVA investigates or examines the effect of one factor on only one variable. For example, we may wish to test whether the three different types of beverages result in different body weights in humans. Here, the effect of only one factor, and that factor is beverage type, on body weight, is considered. One-way ANOVA is said to represent a completely randomized experimental design, sometimes abbreviated as completely randomized design. The table here shows the summary table of one-way ANOVA, where we have various sources of variation. We have the total, treatment, error. On this part, we have sum of squares, degree of freedom, mean of squares, F-value, and F-critical. The second type of ANOVA is the one referred to as two-way or two-factor ANOVA. Two-factor ANOVA has to do with the simultaneous investigation or analysis of the effect of two factors on only one variable. For example, one may wish to simultaneously analyze or investigate the effect of hormone treatment called F factor A and sex, call them factor B, on calcium concentration being the variable in a population of bears. Two-way ANOVA is said to represent randomized block experimental design, sometimes abbreviated as randomized block design. This table is a good representation of two-way ANOVA table, where we have two F values, that is the F calculated, and two F critical, that is the F tabulated. The next type of ANOVA is the three-way ANOVA. Three-way ANOVA assesses the first of three factors, say factor A, B, C, simultaneously on population means. For instance, one may desire to find out the effect the following factors like low temperature, medium temperature, and high temperature have on the rate of oxygen consumption on crops. Three-way ANOVA is said to represent the Latin square experimental design, sometimes abbreviated as Latin square design. This table shows the summary table for three-way ANOVA, where we have various factors like factor A, B, C, and their interactions, their F values, and their F critical. Let's see how to calculate ANOVA. Basically, we have two ways of calculating ANOVA. The first one is by statistical software like the SPSS, GenStat, Excel, and other softwares. The second way is by hand. Calculating ANOVA by hand is very helpful as it aids one's understanding on how ANOVA works. Please stay tuned for the next video where we'll solve some numerical problems on various types of ANOVA. Please don't forget to like this video, leave a comment, share, and subscribe to my channel. Thanks for watching this video. Bye.